so that we can dynamically change the size?
You can dynamically change size as needed, right? So think about basically you have different scenarios. The first scenario is you know the amount of data, you know the amount of memory needed when you write the program. That's scenario number one, right? The second scenario is you know when the program is running. For example, you say I want to process a file, and I can read the whole file once, know how big the file is, then I decide how much memory I need to allocate. But the third scenario is you do not know. So what you're going to do is you allocate as needed and release what you don't need. And that gives us something called, so it's called dynamic structure. In this class, we'll talk about linked list and binary tree. So first, I need to understand the purpose. Then you understand what we are doing. Okay. Any questions about that? So how do you create linked list? You create linked list by first define a type. You need to give a name. Let me say just say L node. Okay, means open. This name is used only once. Is used here. I will say struct L node. We usually call it next. The reason we need this name because compiler look from the top going down, and you need to know what you mean before you move forward. So what this means is you are going to create an attribute as a pointer. And then you can have some data. Let's say you have an integer for the data. You may have something else, character, let's say name. Then here I call it list node. This must be a pointer. Does anybody know why that must be a pointer? You must have a star after L node. Does anybody understand? Did Professor Enquist talk about that? So what's the reason? The address of the next node. Why do we have to use a pointer here?
If you didn't use a pointer, typically it would kind of just act like recursion and go on forever and ever, right?
Right, so the purpose of creating this structure is to tell compiler how much space you need for a node in a list. If you do not have a pointer, if it is not a pointer, that means the compiler has to know the size of an object, right? That means, right, okay. If it is a pointer, then the size of this attribute is the size of the address. I should probably say an address. That means if you are on for a 32-bit machine, then an address is 4 bytes. For a 64-bit machine, an address is 8 bytes. So compiler knows how much space you need for the pointer. It is dependent on the machine. But it's not dependent on anything else. Here, there are some machines that actually the address is neither 32 or 64, but let's not worry about that here. The machines you buy today are probably 64 bits. Your desktop, your laptop is probably 64 bit. So that means if you size of next will give you 8 bytes for your laptop. If probably most laptop you buy after 2008 will most likely to be 64 bit. So compiler knows how much space you need. If it is not a pointer, it has to know the size of the entire object. Since we haven't finished the definition of the structure, then compiler doesn't know what to do. Does that make sense? Right? That's the reason you must use a pointer. Any questions so far? All right, since Professor Enquist talked about insert and destroy, here I'm going to talk about, and he talked about insert in the middle, front and back. Is that right? Okay. So today I will talk about insert in the middle. In particular, I will talk about insert sorting. So I'm going to create a function I will call list node, and I will say list insert what does this function do? So this function will return the head of the new list after inserting the value to the list. And the values in the list are sorted. That's what I'm going to do for this function. I will also create something I will call the node construct. That will create a node. So what this does is I'm going to create a node I will call n equal to malloc. Then I'm going to put the other attribute into comments. So here I will use integer only, but you need to understand it doesn't have to be integer. It can be many other possibilities. For explanation purpose, here I use integer. Then I will say its data is val. Actually, I should say is next. So inside the constructor, I will initialize the attributes. We talk about the purpose of creating a structure. Does everybody remember? Do you remember why we create constructor for structure? Not remember.
So you don't have to have it in the line of code.
You don't have to write the same lines of code again and again when you want to create a node. And what's the advantage?
If we want to change some, like the name of structure, you only need to change it once and not easy to forget.
If you change the structure, you have only one place to change. One more.
It's easier to read.
easier to read, anything else. You will not forget to initialize next. I've seen many students, for some reason, they forget to initialize next. And as a result, next is garbage. When you have garbage, your program will do crazy things. So I always use a constructor to initialize next. Why do we do that? Because next is a pointer. That means pointer stores an address. A node is an invalid address. That means there's nothing after this node. It's the end. Right? Does that make sense? So I'm going to create also, do not call it new, because new is used in C++. So if your C program is integrated into a C++ program, you have a problem. That happens quite often because C++ and C are very much related. It's common. You have one program, one part of the program is written in C, and then later on you say, I need to put things together. I don't want to rewrite a part written in C. I want to put into the whole program, but other parts are C++. Then you have a new here. Then since new is used in C++, it can cause a problem. You will not see the problem in C, but once you integrate them together, you may see problems. That's the reason you should not use the word new. Okay. Any questions so far? Okay. So, when you have something like a dynamic structure, you almost always check whether it is empty. There's nothing in the list. If there's nothing in the list, you create a new node. That's the very first node in the entire list. And since there's only one node, that node must be the head, right? Any questions so far? Does it make sense to you so far? Okay, good. Then if we reach here, that means if the list is empty, we already handle the case. If we reach this point, that means the list is not empty. Then I can compare. If this one is larger than the value I want to insert, that means I want to insert as sorted. So small number is in the front, bigger number is in the back. I want to compare. Make sure you check head is null before you get data. If you do not check, your program will crash on its line. The second if statement. Then, if the new node I want to create is before the head, so this is what I'm going to do. I'm going to say list node. So I create a new node. And I will say its next node is the head. I show you the code and I will draw a picture.
What is list construct?
Oh, right, sorry, node construct. Thank you. consider three scenarios. One is the list is empty, I create new node. The second scenario is the new node has to be before the rest of the list. And the third scenario is the node is somewhere in the middle of the list. Okay, I'm going to put this side by side, and maybe I give you a little bit time to write down your node. And I draw a picture to explain to you how this works. I guess I cannot show both of them. I don't have enough space here. Okay, so let me draw a picture. I put this side by side so you can still see the code. The first, well, let me go back here. So how do you code this? How do you code this? Suppose we another function. So you want to create a linked list. That's called the function f. You want to create a linked list. You will say the following. And you will say head equal to list, insert, something like the following. 1, maybe 7, 4, 2. This is how you use list insert. Let me see whether I can delete one more line so put everything in one single screen. Okay. All right, so let me draw a picture and explain how this program works. When you start, the very beginning, you have the head. Head is a pointer. Head point to nothing. Usually we draw this way. Means the list is empty. Another way to look at this is you have your call stack. List is in your call stack. So this is a symbol, this is address, this is variable, and currently is no. Then you are going to call list insert. It's a function call, so you'll follow the same procedure we have talked about throughout the whole semester. You'll put a line number here, so you have the location. So return location will be this line, the line after the function call. Let's say this address is 100. You have a variable address. It's 100 because you assign something to head. Then inside the function, you have your argument. Now we already talked this many times. This head and that head happen to have the same name. You can rename it. Then you will copy this here, so this will be null. And you have another argument is val. You copy 5 here, so this will be 5. Then inside this function, you have the if statement. If Since head is currently null, your code is node construct. Node construct will allocate memory. So node construct will allocate memory, and then when we allocate memory, that means we'll have something in a heap. And this one will have next and data. When we call malloc, over there, we'll have the two attributes because the structure has two attributes. Let's say this address 20,000. And then this will be null because in node construct, you assign next to null. Then the data will be the value given to the constructor. So this one will be 5. Then you return this address to here, so this becomes 20,000. That's after you finish calling node construct. You return the address of the first attribute. Then you look at this line here, says return. This line, you can rewrite this in the following way. I think I simply make it shorter, but this line here is equivalent to the following 3 lines. That means I'm going to return the variable returned from node construct and then write into the variable address in the call stack. Therefore, I'm going to return 20,000 and the variable address is 100, so I'm going to change this to 20,000, and then this is gone in my call stack. So after the first insert function, head will point to a piece of memory. This piece of memory, the address is 20,000, and data is 5. Next is null. So that's what happens in the first call for insert function. Any questions? This was covered in Tuesday, right? Okay. Now how do we do this in want to insert in order? So consider the next scenario. I want to insert 1. The next is 1, so I'm going to draw this again. Now, head currently points to a piece of memory. This memory is 20,000. Data is 5.
Professor, you're not on the screen.
Sure. That's what we have in the memory. The next line says I want to insert 1. So I say head equal to list, insert So look at my call stack. Head, address 100, the variable is 20,000. In a heap, memory, this is next, address 20,000. Now on a 64-bit machine, the address will need 8 bytes, so I'm going to write this way. So I'm going to call this function, then we'll do the same thing again. Push to the call stack. So return a location. That'll be the line after this. So this will be the line after this. The variable address will be 100 because we assign to head. So argument, now it becomes 20,000. And the variable, it becomes 1. Now if you look at the condition here, the first condition is if its head equals null, that condition is not true because currently head is 20,000. Right, so then it's false. This head value is 20,000. Then the next condition is if head data is greater than val. So head is 20,000. Head data is this one, so this one is 5. Head 20,000. I go to 20,000. Data is the second attribute. So I find data in the heap memory, so it is 5. And val currently is 1, so this condition is true. If the condition is true, you are going to say, you are going to create a new node, right? You are going to create a new node. Then what happens is n is node construct 1. So you will allocate another piece of memory in your heap. Let's say it is 30,000. You have next and the data. Next is null because inside the constructor you initialize null and the data is 1. Are you with me? Good? Good? Okay. The next line says n's next is head. Right? N is value is 30,000. So n's next is head. Head is 20,000, so you change this line to 20,000. That's what this line does. N's next is head. And then you say return n. N's value is 30,000. You return n. 30,000 is going to write to address 100. Therefore, this becomes 30,000. So after the insert function finishes, this is what this one gets popped. This is what in your stack memory. This is what in your heap memory. This 30,000 point to this place. So after the insert function returns, this point to 30,000. Data is 1. Next is 20,000. So it points to 20,000. Data is 5. Next is null. Let me zoom out a little bit so you can see the whole thing. So I have inserted a node before the list. Right? Does that make sense? Make sense? sense so far? Okay, give you time to think. Good? Straightforward? Reasonable? Okay. So let me now consider the scenario when I want to insert, let's say I want to insert 2. Let me change the order here so that I don't have to do too many. I just put 2 in the middle. Oh, sorry, not there. There. So I want to insert 2. Currently, my linked list looks like the following. Head points to data is 1. Next is 30,000. This data is 5. And next?
We can't see.
Okay. Sure. Sorry about that. That's what my linked list looks like right now. So in terms of heap memory, stack memory, and in terms of heap memory, you have next data. And here, let's say next. That's what the memory looks like. Now I want to do this. Head equal to list insert head 2. So you know we want to do sorting. Therefore, this node must be somewhere in the middle. Right? Let's see how it works. So I have return location. That'll be the line after this. I have a variable address. That's 100 because I assign to head. Then head equal to 30,000 because I assign that here. And the variable is 1. Oh, I'm sorry, 2 because that goes here. Okay. So then I go to the insert function. The first thing to check is if head, right? So if you look at the insert function over there, that's what we check. It's false. Because head value is 30,000. It is not null. The second condition is if head data is greater than val. Head is 30,000. Head data is 1. Therefore, this side is 1. Val is 2. Is 2. So this is also false. Okay, any question so far? So the second if condition is also false. Therefore, I'm going to go to the next line. Is head next is list insert heads next. What's heads next? So we are going to call a function and we follow the same procedures. We have a return location. It's going to be this line, the line after the function call. And the variable address, what's the address of this? What's the address of this?
3,000.
What's the address of this?
20,000?
What's head? Head is 30,000. What's head next? Head next is this one. What's the address of this thing?
30,000?
What's the address of this thing?
30,000.
Louder.
30,000.
Who thinks 30,000? Raise your hand. Raise your hand. Who thinks 20,000? Okay, who thinks, for those people that have not raised the hand, what do you think?
20,000.
You think 20,000? Okay, let's consider. What's head? Head stores 30,000, so we come here. Do you agree? What's head next? Head next is this, right? Is this thing here. Are you with me? Okay. What's the address of this thing?
The address,
The address of this thing, yes, I'm pointing to now.
30,000.
30,000. So the address here is going to be 30,000. You agree? I'm not talking about the variable, I'm talking about the address, right? It's on the left side. So I want to use the address. If you write 100 here, that means the address is head. Therefore, if you do this, you are going to go to 30,000 and see what's the address of that thing. That's 30,000. Make sense so far? So I know the variable address 30,000. When the function returns, I need to write something to 30,000. Does that make sense? Okay. Then I have head is going to be, actually, this head is coming from this one. Right? Are you following? Kind of? Good?
Yeah, I think so.
Okay. So what's the variable of this thing? Now this one I need variable because I'm not using this. This one will give me address. Without ampersand, I need a variable. Right? This one will give me variable. With ampersand will give me address. So this one will give me variable. Head next is location 30,000. What's the variable of that? 20,000. And val is going to be 2. Why? Because I copy the val here. Okay, make sure you understand why is 20,000 here and why is 30,000 there. Any questions? Do I lose you completely? How are we good? You think?
Yeah, okay.
Brian, right? Are we okay? All right. 志阳, is that? Are we good? Okay. Okay. So now I come to this function. Then I need to check the first condition. If head is null, head is not null. It's 20,000. Is head data larger than val? Head is 20,000. So I go to 20,000 and find the data is 5. So current now the data is, I should get another piece of paper. Now I'm on the top frame here. So I will say if head data is greater than val. Head is 20,000 now. Head data is 5. So therefore, this is 5. And this is 2. Therefore, this is true. If it is true, I'm going to enter this condition. I'm going to do this. If that is true. So, I'm going to call the construct. N is going to be node construct 2. Because the value is 2. When we call node construct, we are going to allocate memory. So suppose I'm going to allocate memory here. Suppose this give me 40,000. And node construct will initialize to node. And data will be 2. So this line is going to create allocate memory in heap. Then going back to this set of these 3 lines here, S next is equal to head. So I say N's next. N now becomes 40,000. So N's next equal to head. N is 40,000. N's next comes here. N's next is equal to head. Head is 20,000. Therefore, I change this to 20,000. That's what this guy does. And then I say return N. Return N. N is 40,000. The variable address is 30,000. So I'm going to return. This means I'm going to return 40,000 because N's value is 40,000. I want to write 40,000 into the address 30,000. Therefore, this becomes 40,000. Why? Because the value address 30,000. This function returns. Therefore, this top frame gets popped. Then this function, if you look at the end of this function, we came here. And then it says return head. So I'm going to return now I say return head. So I'm going to return head 30,000. 30,000 will write to address 100. So I write 30,000 to 100. It happens it does not change. So after the function returns, of course this top frame is popped. Now this is what the linked list looks like. Head point to address 30,000 and the variable data is 1 and next is 40,000. So we point to 40,000. The data is 2. And the next is 20,000. So 20,000 data is 5. So we have inserted in order. We'll take picture of this. Are you done? Take picture. Okay. Any questions? The trick here is you use, let me go back to this. You use the call stack to remember things. You use the call stack to remember the head and when you move forward. In particular, if you look at this line here, this line. This line says head next equal to insert head next var. This function, this insert will return either the newly constructed node or return head, right, at the bottom. So another way to think about this is when you call this insert, look at this line. If it falls to the last line here, it says return head. That means when you call a function, you say list next equal to head next equal to insert head next. And if you follow to the bottom line here, that means you are not changing it. And that is what's happening in this case. Head next is, so head is 30,000 and you return head, so you are not changing it because your first node is already the smallest value. That's the reason you are not changing it. Any questions? This needs to be time to think. No questions. So next I'm going to write how to delete a node. Okay, before I move on, any questions? Going once? Twice? Why are you smiling? Too easy? No? Reasonable? Somewhat. Yes, you are laughing. Why? You learn something new?
Can you remove this favor? Can you explain again why that head next is pointing to
Which line?
the head next equals to list insert?
You mean this one?
Yeah. Why is it pointing to 30,000?
What is, say that again?
Why the value of head next is 30,000?
Why, you mean the left side or the right side?
The left side.
The left side?
Yeah.
Okay. So we are here, right? We are about to call the function again. So we are not on the top frame yet. Head is 30,000. Do you agree with me?
Yeah.
Head next is here. Right? Head next means this line. Agree with me?
Mm-hmm.
And it's on the left hand side because it's on the left hand side of the assignment. So I need to have the address. What's the address of this line? 30,000. So that's the reason I write variable address 30,000. That means when this function returns, I'm going to modify the variable at address 30,000.
Oh.
Does that make sense? Okay. Do you have a question on this side? No? Okay. Any other questions? Thank you. I'm sure everybody appreciates when you ask a question. Okay, so if there's no question, if you understand this, it's easier for you to understand delete. So I'm going to delete a node in a linked list. And the function returns the new node, the new head, the head of the new list. before I write this function, I'm going to draw the picture for you to understand what it means by delete. Suppose I have a linked list like the following. Let's say 1, 2, maybe 6. It doesn't have to be sorted. Since I talk about sorting, I'm going to assume it's sorted. When we delete, this is what it means by delete. That's why I want to delete node 1. That means to delete 1 means I'm going to move the head to here. And then I release the memory. I should show it here. That means I'm going to delete 1. That's what delete 1 means. You move the head to the second node and you release memory for the first node. That's what delete 1 means. Suppose I have the same linked list. I want to delete 2. That means I'm going to head still point to the first node. But this one is going to jump over to 6. And I'm going to release the memory here. That's what delete means, right? Remember, you need to change this link. Otherwise, you lose the rest of the list. Yes, please.
By delete 1 or 2, do you mean delete first or the second node, or the node with the value of 1 or 2?
Either way, here I use value.
Okay.
Okay. If you want to delete the first node, you need a different way to count. That what it means is in this instead of using value, you are going to say you change this to counter. Okay. You change this one to count. Does that answer your question?
Yeah.
Okay. So I'm going to show you how to delete. And if the list has nothing, there's nothing to do. Right, you agree? There's nothing to do. But you still need to return null because the function has to return a pointer. And since the list has nothing, you just said there's nothing. Because I said the function returns the head of the new list. As I said, for dynamic structures, you almost always see the first line of the function is checking whether the point is null or not. You see that again and again. Because if you don't check, if there's nothing, you cannot do anything, right? Now the second is I want to say one more thing here for the insert. Sorry, I go back. The insert, if you insert same value twice, they will be next to each other. This function, insert function, does not ensure the values are unique. So if you want to think about how we prevent inserting the same value again, that will be a good exercise. Okay, this does not prevent inserting the same value again. So you may have 1, 2, 2, 2. You insert 2 3 times. Just to make sure you understand that. If the data is the same, if the node you want to delete is the first node, because head points to a first node. So this is what you are going to do. You are going to say Now, how do we call this delete function? Maybe let me go back up here. So you will call it in the following way. Let's say 4. Oh. Or you can delete 1, or 3, or 5. That's how you call it. Now let's look at the drawing here. When we delete the node, let's say the node, we want to delete 1. That means I'm going to move this to the second node and then release the first node, right? So if you look at this piece of code here, if the value is the value you want to delete, in this case, if you want to delete 1, that will be this case. Then by returning the node of next, the head next, that means I'm returning the address of the second node. So I'm returning this node. P, look at this line. P equal head next. So that means P is another pointer, P points here. Then you release this node, so you get rid of this node. Then you say free head. Then you say return P. That means, and since this function is called by assigning the value back into head. Pay attention to this assignment. Therefore, when the function finishes, you are going to make its head point here. When the function finishes, P is gone because P is a local variable. So your new list will be this way, and that's exactly what we want. Yes?
When you pass head as a single pointer, can you pass it as a dual pointer?
What do we do a pointer?
List nodes now started.
You can do that.
So then how do we access data of head?
Okay, so if you want to so your suggestion is to do this. Let me see. Is that what you want to do?
Yeah. I just want to see how you access the value of data then.
Okay, in that case, I'm going to say this node, let's say P equal to head. I want to dereference it first.
And then I see P of data.
Then you can say if P or something like that.
Is there anything I can do to directly access it?
Yes, you can, but I wouldn't recommend. So basically, this is what you are going to do. It's kind of tricky. It's error prone. I wouldn't recommend that. You know what I mean, right? It looks ugly and it's easy to make mistakes.
Also, if head is a single star pointer, then can
So,
I say
I wouldn't recommend that way because it's easy to make mistakes. Yes.
so if it's like this, right? There's no star head, and then I want to access the data of the next value. Can I say head of next of data?
Yes, you can do that, but you have to, before you do that, you want to say access the data of the next node, right? Now, if we are here, we know head is not null because we checked earlier. But we do not know head next is not null. it's possible, that's not that's null. So you have to say first, you have to say head next. Then you can say if you can see it's getting a little bit. Then you can do whatever you want to do. Does that answer the question? Okay. Make sure you check before you use it. Okay. So if you want to access the data of the next node, you have to check that before you use data. But we don't have to go that complicated. I'm going to keep it here, but I will delete it later. Otherwise, you'll say heads next equal to I'll keep that few lines again, but I'm going to delete it. So this will allow you to delete the node if the node you want to delete is not the very first node. If you look at how this works is, if the node you want to delete, let me draw the picture here. Consider a linked list. Let's say head point to, I'm not going to use 1, 2, 3. Because I want to emphasize this variable. So let's say 2, 5, 9, 14, and 20. Okay, suppose that's my linked list. If the node I want to delete, let's say I want to delete 9. Suppose that's what I want to do. Then you look at this if condition. If I'm going to delete the rest so that I don't confuse you. You look at this. There are two if conditions. The first if condition means the list is empty. If I start with the node 2, the first if condition is not true. Therefore, I don't go to the first if condition. I start with 2, right? The second if condition is not true either because it starts with 2 and I want to delete 9. So the second if condition is not true. Therefore, it goes to this line here. It goes to this line here. Heads next equal to list, delete, heads next long. So I try to go to the next node. I move to this one. I'm looking at whether the node I want to delete. So I basically skip the first node, 2. If you look at this, then look at the two if conditions, neither is true. Right? The first condition is the head is null, it is not because I'm pointing to node 2. I mean node 5. The variable is 5. So the first if condition is not true. The second if condition is not true either because the variable is 5 and I want to delete 9. So neither if condition is true. Therefore, I'm going to move to this node. Any questions so far? Why does it? Oh, I think it goes back. Okay. I'm going to look at the node 9 here. Then I come to the first if condition. Is head equal to node? It is not because it points to node 9. I look at the second if condition. It is true now. I want to delete 9, and the node I point to, the variable is the data is 9. Therefore, I have a pointer P points to the next node. That's what this line does. And a pointer P points to the node after the node I want to delete. Then I will release this node, the memory by this node. Then I return P. How do I get here? Earlier I said head next is list delete. Right? That's how I got here in the first place. And this return will return P. That means you are going to change list next. Point to where it points. So I changed this link. Now we need to go back because this node is still in my code stack. So I go back. If you go back to list function, when it is 5, for 5, neither condition is true, therefore it does not enter either condition. And what does it return? Return head. That means you will return 5 and write to here. So you will do that. It is not changed. The only thing you change is when you reach the node you want to delete. And that is handled by this line here. Oh, I think you cannot see. Let me show it to you. So you will return head. Head currently is 5. And you assign back to the next of the previous node. So you assign this again. But that doesn't really make any difference, right? You are not changing anything. You should not change anything because you are not deleting 5. The only time you change is you reach the node you want to delete. You return the node after this node. That's this second if condition. By doing this, you can change this link. The key here is this link. Again, you are using a call stack to keep the data for the head. And because you keep the head, you keep the next. Because head stores the address. Yes, please.
If we have say two value 9s in our list, in this function cannot delete both.
This function does not delete both. It will delete only one. And which one does it delete? Okay, so let me repeat the question again. Let's say you have your link. Earlier I said the linked list, the way we write the insert function does not prevent you from having two nodes of the same variable, but it does ensure that variable will be next to each other. So if you insert 9 twice, this will be your linked list. And if you want to delete 9, so what will happen? What do you think? Are we going to delete, I said 9A. So question number 1, answer number 1, delete both A and B. Answer number 2, delete A only. Answer number 3, delete B only. Answer number 4, neither. Which case do you think? Which case do you think? Is that your question? Okay. You answer the question. Yes, not your question?
No, my question was how do you write the functions when both are deleted?
Let's answer this question first. So what's the answer? Delete A only. You'll delete the very first one. Right? Because if you look at the program, you will delete the first one that matches. So you delete the very first one. So his question is, what if you want to delete both of them? In that case, you can write a loop, or you can have another. So this if right? Okay, so if you want to delete all of them, I'm going to write another function. Okay. In that case, you will, let me see. I think I will do a flag here and make means I have deleted. And then here I will say you probably know what I'm going to do, right? And so if I cannot delete anything, I reach the end of the list, I say don't not delete anything. If I can delete something, I set it to 1, and then I say while flag. No, I should put 0 here. Does that make sense? So instead of deleting only the first one, I want to delete all of them. So if I can delete one of them, I say I have deleted 1, but I don't know how many I need to delete. Every time I call a function again, if I cannot delete anything, I reach the end, I don't delete. So that's the first if condition. I set flag to 0. This means you have nothing to delete, right? If I had deleted something, have deleted 1, then as long as I can keep deleting, I keep going through. Does that make some sense? Okay. Any other questions? I think you know the list is not going to be in the exam next week, but you still need to know. Okay. So next Tuesday, please bring your questions for the exam. If there's no question, I will talk about new material. If there are questions, then I will be happy to answer questions. All right. See you later.